how to express the faculty in terms of the gamma function. The faculty is a really useful method for calculating permutation and very useful in statistics. But regarding statistics, it would be more useful if the faculty would be indeed a continuous function in R. If you look at the graph of the faculty, you see it at some point and with gaps in between. So it would be really nice if we had like a function that would fill in the gaps and is continuous in R. Does the function exist? Yes, it does. It's called the Euler gamma function, which is a function of x, the integral from 0 to plus infinity dt t to the power of x minus 1 e to the power of minus t. In the first time, there's no connection between the faculty and the Euler function. But the Euler function has a really useful property. Gamma of x plus 1 equals x times gamma of x. This is really important, so I will mark that. Maybe let's change the name of the variable. Let's name it n, so we are more familiar with the property. Let's do a quick proof on that. And it's really not too complicated. If we look at our integral for the case n plus 1, it's just n here, e to the t to the power of n, e to the power of minus t. If you see that, what do? Yes, integration by part. So let's take e to the power of minus t because it's easy to find an antiderivative here. So that's minus e minus t. T to the power of n stays same. And we have to take the result at the boundary minus 0 to plus infinity dt. Then we have to take the antiderivative from there. So minus e. Let's compute this term directly. So if you take plus infinity at this term, so e to the power of minus infinity will be 0. And if we put in 0, e to the power of n will be 0. So it's 0 plus 0 equals 0. So we can neglect this term. If we look here at this term, we can cancel the minus here and put it a plus here. So, and we can also take the n and pull it out of the integral because there's no dependence to t. So, what do we have in the end? We have n integral 0 plus infinity dt e to the minus t and e to the power n minus 1. And if we look at the definition of our gamma function, this term, the gamma function for gamma n. So we have proven our property. So if we see gamma n plus 1 equals n times gamma n. So we did that. What is the connection to the faculty? I need some space for that. So we have this property is proven now. So let's write it down. But this is true for every n, or for every x, if we want to say it more generally. So let's just continue. So We can also do the same thing with n minus 1. So this works. And let's not stop there. So n minus 1. Point, we continue 2 till we reach gamma of 1. What is gamma of 1? Let's look at it. So if we put in x equals 1, this is just 0, so t to the power of 0 is 1. So we just have to calculate the integral from 0 to plus infinity for e to the power of minus t. And we do this fastly. So this one, we can directly write the antiderivatives. It's very trivial. And we know that at plus infinity, this one is 0, so we can neglect that. So we only have to look what the value of this term is for e equals 0. So e to the power of 0 is 1. So minus 1 minus 1 equals 1. So this term equals 1. So if we just see it, n times n minus 1 point 2 times 1. It's just the definition of the faculty. So let me put final arrow here. So we have proven that gamma n plus 1 is in fact the faculty. So we have found a continuous function that can express the faculty. Amazing.